Good day, this is Romano Montajes. For today's video, we're going to discuss the simulation of our chemical sensor pH, the performance. Our aim is to study the working principle of chemical sensor. Then our objective is we have four: study the working principle of pH and conductivity sensor. And the second one is calibrate the pH sensor. The third one is to study the effect of temperature in the pH measurement. And number four is to study the effect of temperature and effect of contamination on conductivity measurement. So let's proceed with the pretest. Our pretest simulate the performance of chemical sensor pH. Number one question is, when the hydrogen ions concentration of a solution increases, the solution is called as A. Acidic, B. Basic, C. Neutral. The answer is letter A. Acidic. For number 2, the pH of neutral solution is A0, B7, C14. The answer is letter B. For number 3, the pH scale generally ranges from A0 to 14. That is letter A. pH of distilled water is A0, B7, C14. The answer is 7. Number 5. Buffer solutions are used as means of keeping pH at a nearly blank in a wide variety of chemical applications. A. High, B. Constant, C. Neutral. B. Constant. At number 6, conductivity of pure and distilled water is A. High, B. Low, C. 0. The answer is letter C. 0. And number 7, the current through the solution takes place through the movement of A. Electrical charged particles, B. Chemical charged particles, C. Magnetic charged particles. Letter A. Electrical charged particles. Number 8, the SI unit of conductivity is A. Ohms, B. Ohms per meter, C. Siemens per meter. The answer is letter C. Submit. Okay, 8 out of 8. So after answering the pretest, let's go to the pH theory. We'll just have a peek for the theory. This is the theory. Send the preference chemical sensor, pH measurement. The working principle, we have this one. The calibration of pH with buffer solution. And then the installation of related issues. For conductance, in here, sa theory niya, we have this one, the accuracy of conductivity measurements can be influenced by the following factors. Number 1, polarization. Number 2, contamination. Number 3, geometry. Number 4, frequency change temperature. We have this also table here for constants A, 0, A, B, and the conductivity simulator to solve the equation using the format of data. So this, well, let's go to the pH simulator. Now click here for simulator. And this is the diagram for our pH calibration at level 1. We have here from our illustration for calibration diagram, we have this wire, this pH electrode, and this glass ball. This is standardized solution. This is our control panel, and initial pH value 7, and our room temperature is 27 out of 25 degrees Celsius. We select, let's say 4, it will yield or it will present the pH values here. If we select 0, that will give us 414 output NV. If we select 4 pH, we will get 177 output MV. Now if we select 7, we would get 0 output NV. And if we select 14, we will get negative 4114. 414. So this is the plot. This is the plot of our diagram, of our data. This one, as our MV as our output MV getting higher, we would get a what? We would get a concentrated or acidic pH value, meaning we would get a lower uh, value of pH out of scale, no, from the scale of 0 to 14. Now, as we decrease the output MV, it will give us uh, a great number of pH value, which means to say that we would get our solution is basic, tend to become a basic solution, just like this one. At 14 pH value, your output is what? Your output is negative 14 or negative 414 output MV. Now, as we have our pH value of 7, we would get 0 pH value, like this one. And as we get the 4 pH value, we would get 177 output MV. So that's the plot. Now next, with the level 2. For the level 2 naman, for our pH calibration, level 2 is the measurement. If we select the sample, so we have these choices here: lemon juice, fruit vinegar, orange juice, boric acid, coffee, milk, distilled water, seawater, baking soda, ammonia, bleach. These samples are options, are your options, and you have to select either of them. So yeah, let's say lemon juice. We select lemon juice, and automatically it will give us a value of pH, which is 2.2. Now, what we're going to do here is to calculate the output MV. Now, you are going to calculate the output MV by using this formula. Formula calculation of output MV is equal to millivolts. This one, PO minus 2.3026 times R times T slash divided by F times the PHC times 1000. Your PHC is your pH value deviation from 7 in the formula. Your F is Faraday's constant. That's it. So you will going to use that one to find your output MV. Now, at lemon juice, so after calculation, you put your answer here. You put your answer in the box. 2.823.97. Then after inputting your answer, you click submit. Then if it is correct, then it will appear, it will turn to green. But if it is wrong, it will turn to red, meaning you will go to recalculate. Then after calculating this one, you have this 283.97. So let's go forward. I wait. From our diagram here, we have this bath solution, pH electrode, and the wire high impedance buffer amplifier display. So we're going to select this one, level 3. So after level 3, that is the level 3, the temperature. Even with the output value, the temperature, which is 283.97, diba? Kalabas siya din. Temperature. So as we this one, the get temperature, this is at 23 degrees Celsius. what would be our output MV? We would get 82.06. Given that your sample has a pH value of 2.2. Now, if we change the temperature again from 34, what would be the output value? It would be 292. Output value of MV, it would be 292.54. How about if we change again from 38 to into 38 degrees Celsius? We would get 296.35 output MV. So that's it. So let's see in the plot. Ano yung itsura niya. So this is the illustration of our graph. This is the output MV, our abscissa, our coordinate, and then for our abscissa we have this pH, and it is saying with the level 1, a level 1, level 2. As our output MV increases, it would give us a lower value of pH, meaning concentrated at magiging concentrated siya, acidic. As we decrease our output MV, or as we increase our pH value, we would get a less value of output MV. Which means if we have 14 pH value, we would get somewhere here, that is negative 432.17 output MV. So that's it for pH calibration. For pH calibration first, for the level 1, what we do in level 1 is we do the calibration by having this different pH value. We know that as we increase our pH value, we would get a lower output MV. Then as we decrease our pH value, we increase our output MV. So that is for level 1. How about for level 2? Our level 2 is about measurement of output MV. We are calculating here the output MV given we have the samples. Given we have samples, then also our pH value, then we would determine what is our output MV. And also we know here that for level 3, we also know that in level 3, as we select our sample solution from level 2, it would proceed in level 3 for measuring temperature. Not measuring temperature, variation of temperature. Then as we change our temperature, as we increase our temperature, we also increase our output MV. So that is the what happens here. As we increase the temperature, we increase also the output MV. As we increase our pH value, we decrease our output MV. So that is the conclusion. So after the calibration, let's go back to procedure discuss. So after we're done with the pH simulator, let's do the post test. So by clicking this post test one here, so simulate the performance of chemical sensor number 1. pH is measured of the activity of blank ions in the sample. A. Hydrogen ion. B. Carbon ion. C. Oxygen ion. The answer is letter A. Hydrogen ion. In pH measurement, optimum measurement accuracy depends on A. Solution concentration, B. Salt bridge and measuring electrode, C. probe length. The answer is salt bridge and measuring electrode. Number 3. Electrolytes are substances containing A. Ions, B. cations, C. anions. The answer is letter A. Anions. Electrical conductivity is measure of availability of solution to carry blank. A. Current. C. B. Resistance. C. Inductance. The answer is letter A. Current. In conductivity measurement, blank migrate to the negative electrode, blank to the positive electrode. The answer is letter, not letter, but cations and anions. The accuracy of conductivity measurements can be influenced by A. Polarization, B. Contamination, C. Both polarization and contamination. The answer is letter C. Both polarization and contamination. Submit. Okay. Then take a quiz again. So after we're done with the post test, let's do the review questions by clicking this one. So we have six questions here. For number 1, what is meant by pH? Described the working pH meter. So what is meant by pH? Describe the working pH meter. pH meter is measuring how acidic or basic your solution is. It ranges from 0 to 14, as we all know. 7 is the neutral, that is the pH value of distilled water. And it is really a measure of pH is really the measure of the relative amount of free hydrogen ions in the water. pH meter electrically device used to measure. So are going to describe the working pH of the meter. It is electrical device used to measure hydrogen ion activity, acidity or alkalinity in solution. Fundamentally, a pH meter consists of a voltmeter attached to pH responsive electrode and the reference, which is your unvarying electrode mo, yung reference. When the electrode are immersed in a solution, they act so as a battery. Kaya, di ba, from the setup, your reference electrode is facing downward, which is mounted vertically 10 degrees from the abscissa, 10 degrees above from your abscissa. So it must not be low with 10 degrees. It must be mounted at your And then number 2, what is the question number 2? Describe the calibration procedure for the pH meter. First is we're going to examine the pH electrode. First check the letter for contamination or damage. So that is the first and must thing that we do in the laboratory. Then letter B, the second one is flush the pH sensor. Next, flush your sensor with the distilled water. Why is that? Para to eradicate some unwanted chemicals that could contaminate our solution. Letter C, immerse the pH electrode. I-immerse natin siya yung pH electrode. Then calibrate the pH meter. So from our theory, the buffer solution is in 4, 7 and 9.2, di ba? And tayo doon yung sa pagka-calibrate. Then rinse the pH sensor and repeat for a safe and para makasigurado that there is no contamination that will occur. For number 3, describe the construction and principle of working of a conductivity meter. So, the principle by which instrument measures conductivity is simple. To have 2 plates are placed in the sample. You have 2 plates, then the potential is applied across the plates normally in a sine wave voltage, and the amount that passes through the solution is measured. So we have this we have this negative and this positive, and we have this yung parang that will excite the two. charges, creating current, and that will be measured. Number 4, what is the effect of temperature on the measurement of conductivity? Well, as the temperature of the solution increases, we are also increasing our output MV. So the mobility of the ions in the solution also increases. And consequently, this will lead an increase in its conductivity. Kasi magkakaroon ng, tag doon, yung more collisions in the uh, particles in our solution. So, therefore, it is mandatory to always associate conductivity. No measurements with the reference temperature, mostly or mas preferably ang ginamit natin with what we use pH probe probe temperature is at 25 degrees Celsius, or in Kelvin that is 298.15. And for number 5, discuss any 3 applications where the conductivity meter is used. Okay, so an electrical conductivity meter or EC meter measure the electrical conductivity in a solution. So it has a multiple application in research and engineering with the common usage of hydroponics, aquaculture, aquaponics, and freshwater systems to monitor the amount of nutrients, salt, or impurities of the water. So that is the very main goal of this topic, of this lab that we have. So it is applied in determining the impurities in the water or the amount of nutrients or salts in the fish system water could be. So, mga analysis, something like that. So, number 6, what are the advantages and disadvantages of conductivity meter? Reliability and repeatability are excellent. So the principal drawback of the conductivity is that it is non-specific measurement. So it cannot distinguish between different types of ions, giving instead a reading proportional to the combined effect of all ion present. So that's it for the review questions, for the 6 review questions. So thank you and